Dumelang guys, I hope you're all doing so well. Welcome, Kritovs. On today's lesson, we're factorizing cubic functions. So factorizing cubic functions is all about calculus graphs. We're going to talk about how to find factors of a calculus function or of a calculus equation. Now, when we talk about a cube, you know what a cube is: an equation with its highest degree as 3. Maybe you can have a to power 3. This cube, we're going to talk about this cube. We can have a to power 3 or an equation with x to power 3, as long as the highest degree there is 3. The highest exponent is 3. That's a cube function. I hope you can literally hear me. Now, there are many ways to factorize a cubic function. Basically, we're going to talk about graphs of calculus and finding the factors of its function to draw, for us to be able to draw the graph. So our ultimate goal from here is to be able to draw the graph of a cube function. That's our ultimate goal. And before you can draw the graph, we need to know the factors, or we need to know the coordinates of the x-intercepts and y-intercepts. Yeah, we need to know how to factorize a cube function through that way of finding the factors or the coordinates of the intercepts, basically, guys. So one of the ways to use to find the factors of this function is through the concept of inspection. It is one of the ways to use to find factors of a cubic function. Inspection. Inspection. This is one of the ways we use to find factors of a cubic function. And in that inspection, there is this theorem that you need to know: factor theorem. Factor theorem. Now, factor theorem is all about testing values from 1 up until infinity. Up until infinity, from maybe 1, -1, 2, -2, 3, and so on and on. Which means it goes to -3, -4, -4, 5, -5, 6, -6, 7, -7. All those values. You need to plug these values where you see a variable in a function, and the y value or the y coordinate must give you 0 there, which means our ultimate function must give you 0. When you plug these values or these factors, they must give you 0, our answer. So, and if they give you 0, that particular value is our factor in the function, basically. For an example, let us make an example. A typical example. If you have f at x is equals to x cubed minus 4x squared plus x plus 6. Here's a function. They will say find factors or find x-intercepts, basically. That will be the basic question. Could they find intercepts or draw the graph of this function? This is the basic question they love to ask. So, to find factors of this equation, this cubic function, you need to use factor theorem. The very same factors I've written there: 1, -1, 2, -2, 3, -3. Those factors, we will use them to find our y be equal to 0. Basically, our function or f at x will be equal to 0 at the ultimate goal. So I'm going to try to shoot 1 there, -1, 2. I stop on any factor between these factors, all of them, as long as there's only one that's going to give me 0. as my y value, I will stop there basically. So I'm going to start at 1, f at 1 equal to 1 cubed minus 4 times 1 squared plus 1 plus 6. So this expression on my right should give me 0. Then I will know that 1 is my factor. If it does not give me 0, I go past to -1. If this -1 does not give me 0, I go past to 2, and so on. And as long as I continue, this equation does not give me 0, I still need to continue up until I find that one factor gives me 0 as my y. So I'm going to have 1 cubed minus 4 times 1 squared plus 1 plus 6. It gives me 4. That means I don't need 4. I need to find 0. Then I can go to f to power f times. I can go to f at -1. F at -1. If I put -1 where I see x, let me just put it where I see x. We put in -1. Guys, yeah, we are test driving here. -4 times -1 squared plus -1 plus 6. It gives me 0. Yeah, guys. Wait. Let me just put it properly. You must put -1 where you see x. Hurry, guys. Let us put -1 properly plus 2 plus 6. Okay. -1, -1, -1. So guys, when I put -1, we have got factors of they give me 0. Therefore, this one is our factor. This -1 is our factor. But remember, when you solve for any equation, maybe a quadratic equation or even this cubic equation, you introduce brackets. And when you introduce brackets, this -1 will change its sign to positive, which it means we're going to have in brackets x plus 1. Therefore, we're going to have something like this: x plus 1 is a factor. So when this -1 comes inside the bracket, it changes its sign, vice versa. And when we have 1 here, we're going to have x minus 1. When we have -1 here, we've got x plus 1. So x plus 1 is a factor for this equation. I hope you can hear me, guys. That's how you find it. Must give you 0. If it gives you 0, therefore that particular factor is our factor, basically. And if you put this inside the bracket, you're going to have, it's going to change its sign from negative to positive. That's how you simplify the function. Now we're going to have f at x is equals to x plus 1. Then on the second bracket, we're going to have a quadratic equation. And get so that when you multiply this first bracket, we're going to have the very same equation. So on our second bracket, we'll say which factor can I multiply with x and get x to give us our first term. Which factor can I multiply with our x here to give us our first term? Basically, which value or which variable can I multiply with x to give me x cubed? So that I can put it here. I need to put x times x squared and x times x squared x cubed. It gives me my first term. X times x squared x cubed. Plus, we don't know our middle term. So we're gonna have b x. Now our last term. How are we gonna find our last term? Our last term is a constant. Our last term is a constant. That means we have a constant here. So how do you find which number can I multiply with 1 to give me positive 6? Which number can I multiply with positive 1 here to give me positive 6? Is positive 6. So we're going to have plus 6 here. Yeah, well, guys. Plus 6 there. Yes, we're going to have plus 6. Now, we need to find the value of b. How do you find the value of b? How do you find the value of b? Let us use that trick. How do you find the value of b? Now, the value of b is our middle term. Ne? The value of b is our middle term. Ne? The value of b is our middle term. So now, let us do this. On our equation here, we must look for a factor or a term with x or with a variable raised to power 2. This one again. Negative 4x squared. Negative 4x squared is equals to. You do this. You take our term with a squared as our power and you check here which term can I multiply to give me x to power 2. It means just look at this thing. It must give us 2 x to power 2. So which term can I multiply? Which 2 terms here can I multiply to give me 2 squared, irrespective of which values to use? So we know if I multiply 1 times x squared, 1 times x squared, it's going to give me squared. 1 times x squared x squared. Another one is which one? And it is 1 times x squared. We know x times bx. You're gonna add them, so you're gonna have plus in the middle. You know x times bx, because x times x x squared. 1 times x squared x squared. Yeah, guys, you look for 2 terms that you can multiply to have x squared as our ultimate answer when you multiply them out, because we have 1 times x squared, we're gonna have x squared. X times bx, you're gonna have, I get to answer x times bx x bx squared. Yeah, so yeah, that's how you do it. So we have bracket 1 multiplied by x squared. You're gonna have x squared plus x times bx. You're gonna have bx squared. Yeah, so basically you need to find b. That's our ultimate aim, is to find b, the value of b in this equation. Yeah, guys. What's 1 times x squared is x squared plus x times bx bx squared equal to negative 4x squared. This is an inspection, basically. This is an inspection. We're still here on inspection, guys. Then you need to solve for b. Then I take this negative, I take this x squared to the left, Then I can simplify in any way you want, but as long as it makes sense. So I'm going to have negative 4x squared minus x squared equal to bx squared. Then negative 4 minus 1 is negative, like terms, x squared is equals to bx squared. And to be left with b. I am multiplying here, so I'm going to divide both sides by x squared. X squared, x squared. Then b is equals to x squared divided by x squared negative 5. Therefore, the value of b is negative 5. Therefore, f at x is equals to, remember, x plus 1, x plus 1, close bracket, x squared, x squared minus, b is minus 5, minus 5x plus 6. These are factors of our cubic function. But this is a quadratic equation. You can go further by finding, by opening 2 brackets, because of x squared. This is a quadratic equation. You can open 2 brackets. You can use quadratic equation to find factors of this quadratic equation. So you're going to have x plus 1 when I can use quadratic equation to find factors of x squared minus 5x plus 6, I mean I can just open two brackets and speed failure. Factors of x squared k x. You can use quadratic equation. Quadratic equation can work here to find factors of this equation again. Factors of x is x. Factors of x squared is x and x. Which number can I multiply to give me 6? Add or subtract to give me -5. So what are factors of 6? So I'm gonna teach you how to find factors through this way. Ne? So we need to find factors which can multiply them to give me 6, add or subtract to give me -5. So factors of 6 again, 2 and 3. Then which number can I add to give me 5? 2 plus 3. And which two factors can I add to give me 5 or subtract? I you know go to -2 minus 3. It gives me 5. Which number can I add, or which two factors can I add to give me 5, or can I subtract to give me 5? You know good -2 minus 3 -5. Yeah? 2 plus 3 is 5, so it's the same thing. Then 2 times 3 is 6. 2 times 3 is 6. Now which one is suitable between 2 plus 3, -2 and 3? So you already know good 2 and 3 are indeed factors I'm going to use on this equation because they are common. In 6 and 5 we have 2 and 3, 2 and 3, 2 and 3. That means 2 and 3 are common in 6 and 5. Ne? So I'm going to write 2 and 3 here. 2, and irrespective of where do I write them, as long as those factors are common. Ne? Now the sign is our role. Which signs can I multiply here and here to give me +6? So the sign of a middle term takes the sign of a bigger number. The bigger number takes the sign of a middle term. Which one between 2 and 3 is bigger? It's 3. That means 3 is going to take the sign of a middle term, which is negative. Now, then which sign can I multiply with this negative to give me +6? It's negative. Because negative times negative is positive. Therefore, -2 minus 3 is -5. I'm correct in that case. This is how you find factors of this equation. So -1 is a factor, 2 is a factor, 3 is a factor. These are intercepts. These are x-intercepts already. These are x-intercepts of this function. X-intercepts of this cubic function. I hope you guys can hear me. I hope you guys can literally hear me. I hope you guys can literally hear. Second method is synthetic division. Synthetic division. Synthetic division. Synthetic division. It is seen by, so now how do you use synthetic division to find factors of a cubic function? So first thing first, we have an equation here, f at x equal to x cubed minus 4 x squared plus x minus 6. And here's a function or equation. And yet now for synthetic division, first method to use is factor theorem. Before you can use synthetic division, you must go through the factor theorem method. So now factor theorem method, go to you use factors from 1 up until whatever, maybe from 1, -1, 2, -2, 3, -3. So between those factors, there's only one factor that you need, so that when you substitute where you see x, you put in that factor. If it gives you 0, therefore that factor is a factor basically in this equation. Is one of the factors of this cubic function. So if I can use my calculator and put in 1, then let me just start with 1. So where I see x, I put in 1 to find y, and I need to find 0 as my y. That's my aim for factor theorem. So if I put in 1 where I see x, 1 minus 4 times 1 squared plus 1 minus 6 here. So it's plus 1. It gives me negative 8. When I put in negative 1, where I see x, it gives me negative 12. When I put in 2, okay guys, let me just put properly here. So if I have negative 1 cubed minus 4 times negative 1 squared plus 1 plus 6, it gives me 2. When I put in negative, when I put in positive 1, no guys, I'm making mistakes here. Let me just put in negative 1 properly. It gives me 0, so I was making mistakes. So when I put in negative 1, where I see x, it gives me 0. Therefore, since we have negative 1 here, therefore x plus 1. Remember, when this negative 1 comes inside a bracket, it changes the sign from negative to positive. So x plus 1 is a factor. Now I'm done with factor theorem. So now I'm here using how do you use synthetic division? This is how you use synthetic division here, guys. You draw a backward L-shaped, a backward L shape. So it's a backward L shape. Let me just draw a proper one. Let me just draw a proper one. Yes, here's a proper L shaped. Now, here on top, here, you want to put in the coefficients of x cubed, x squared, and coefficient of x and our constant negative 6. So we have 1 here, negative 4, and 1 here. So here on top, you put in 1 coefficient of x cubed, then on the next one, we put in the coefficient of x squared. On the far right, we put in negative 6. Then next to negative 6, we put in 1 in the middle. Yeah, guys. Then now, here, we put our factor. We don't put in positive 1, you put in the very same factor you got, which is negative 1. Yeah, you put in this negative 1, you put it here, next to our vertical line here, this one. That's why you put in negative 1. Yes, guys. Now, now it's so simple. So how you gonna simplify this thing? So the first method, you're gonna say this one, the coefficient of x cubed multiplied by my factor, which is negative 1. So when I say 1 multiplied by negative 1, this 1 multiplied by this negative 1, keep going, negative 1, then this negative 1 plus this. So the very same answer you got is a negative 1 plus my coefficient of x squared, which is negative 4. And this negative 4, you add it, negative 4. It gives me negative 5. Nearby, guys. Nearby. So where you see negative 4, I just already have 1 as our factor. You put in 1 here. This 1 is our factor already. You put it here. Then you put negative 5 where? Here. Negative 5, you put it here. Never. You put that negative 5 there. Then you are done with the first step. The second step, you take the very same negative 5. You say negative 5 multiplied by negative 1 multiplied by our common factor. I mean our factor is equals to 5. Then this 5, you add it with this 1. Then you say 5 plus 1, equal to 6. And here we are done with my second part. Then you put this 6 where C1. And here then you've the last step, we have 6. And here our answer is 6 multiplied by our factor, and here multiplied by -1, it gives me -6. Then -6 plus -6 plus -6. No, guys, there's a problem here. -6 or plus 6. Yes. Oh, guys, it's positive 6 here. It's not negative. It's positive 6. I apologize. It's positive 6 here. On our equation, it's positive, not -6. So please, apologies there. Yeah, let me just check. Indeed, this factor is our factor now. This -1, where I put in. So I'm gonna have -1 to power 3 minus 4 times -1 squared plus 1. Oh, plus -1 plus 6. Yes, no, I'm correct. It means it is positive here, not -6. So when I have -6, so let me just remove this negative sign here. So -6 plus 6 equal to 0. So our last answer should always be 0 here. Should always be 0. Our last answer. This is our remainder. Our remainder should always be 0. Ne? Yes, should always be 0 here. So now let me just write the full equation. Now, the full equation is this is how it looks like. Ne? This is how a full equation looks like. This is how a full equation looks like. This is how a full equation looks like. Ne? So it's f at x equal to x plus 1. Okay? Already know x plus 1. Second bracket. Here, you're gonna have x times x squared. And here, you know, x times x squared. Now, the second one is -5. So it's x squared minus 5x. So our -5 is gonna carry the x, a variable or coefficient of x is -5. Then our last term is plus 6, our constant there, plus. So we're gonna take only. So this 1, it is represented here and here on this bracket. Then our -5, it is here. Our positive 6, it is here. Then 0 is just nothing and here. Just leave it like that. That's how we simplify it, guys. That's how we simplify this thing here. Now, let me just find factors of this quadratic equation. And so we already have x plus 1. Then you know this is a quadratic, you open 2 brackets. This is a quadratic, open 2 brackets. Factors of x squared, x. Factors of our constant. Factors of our constant, that's when you multiply them, they give you the last term. When you add or subtract them, they give you the middle term, which is -5. You know 2 times 3 is 6. 2 plus 3 is 5. Or -2 minus 3 is -5. And here. Now, the bigger number between 2 and 3 is 3. And here. Our 3, which is our bigger number, takes the sign of the middle term, which is -5. So you're going to have -3. Then I need a sign that I can multiply with this one, with this negative, to give me my last term sign. Basically, negative times negative, you know, is positive. And negative times negative is positive. -2 minus 3 is -5. That means I'm correct. Therefore, this is my function. These are intercepts. These are x intercepts. These are x intercepts. Then you are done, guys. I hope you can literally hear me. I hope you can see how do you solve this equation and how do you find factors of this equation here, guys. Now let us go to sketching graphs. Let us go to sketching cubic functions graph. Let us go to sketching graphs, from finding factors to sketching the function as a whole. Let us sketch the graph now. Sketch the graph. Let us sketch the graph. We have found factors. Now we need to sketch the graph. So I think, guys, the simplest method to use here, is synthetic. Synthetic is simple, but you can use inspection. It's not a problem to use inspection. I don't know which one you will like, but any method in J, as long as you use correct analysis. So it's cubic functions graph sketching. So you're coming to the concept of graph sketching. Now you know the basic function, or the general formula for a cubic function is y equal to ax cubed plus bx squared plus cx plus d. So this is how it looks like, this function. This is how it looks like. Hopefully I'm going to draw a proper function. I don't know. I hope I'm going to draw the proper one. So I'm not good at drawing, guys. So bear with me. I'm not good in terms of drawing functions. But I'll try for the sake of making sure that you understand. Hey, guys. I'm not good at drawing, but hey, this is not how it looks like. I think I've tried. Shame. Perfect. Perfect, ne? It's perfect. I've tried. Yeah. Yes. I'm not good at drawing, guys. So please apologize, ne? But I think this is the basic function or this is the basic graph for cubic function. This is how it looks like. Now, I would explain in simple terms here, or there are features in this graph. So now, at this, let me just change the color. You already know that you have y axis and x axis. Whatever, at this point, we find our intercepts. These are our intercepts. This is our x-intercept, to be precise. Intercepts. That's why we find our x-intercepts at this point. These points are our x-intercepts. Now here we find our y-intercept. And guys, now this graph has got too many, or in most cases this graph has got more than one turning point, couple stationary point. In most cases, not in all cases. So where our graph tends, it is right here. This is where our graph tends. So it tends again at this point. So these 2 points, that's where we find our turning point. Turning point. Sometimes they call these 2 points obviously they are called stationary points. Stationary points. Just a turning point. These are our coordinates for turning points. Now, how do you find the coordinates of our turning point? By letting the derivative of y be equal to 0. So you derive the equation. After you have derived the equation, you equate it to 0 and find x. After you have found x, that those values you found of x, you substitute them back to the real equation. So you derive and solve for x in the derivative. And after you have derived and solved for x, you take those x coordinates you got and put them back to the real equation to find the y coordinates. That's how you find the stationary points. Guys. Now this equation again has got point of inflection. In the middle here, we've got point of inflection. Point of inflection. That's when we want to talk about concave down, concave up, and stuff like that. Concave up, it starts here. Concave down, it starts from this point of inflection again, and it goes down. But at this point, when you come back to stationary points, when you come back to turning points, that's where you find local maximum and local minimum. But we'll talk about that later. Now, in the middle, we have got point of inflection. That's where the second derivative is equals to 0. Then if they say you must find the coordinates of a point of inflection, that's why you just say second derivative equal to 0. Then you solve for x. After you have solved for x, you take that very same x coordinate, you put it back to the real equation and find the y coordinate. That's how you find the coordinates of point of inflection. You're going to deal with those dynamics as we proceed with the topic or with this concept, guys. Yes. Now let us go to, I've explained, so point of inflection, I've explained it. It is where the line or the curve, at this point is where the curve goes from concave up and concave down. And then turning points, couple stationary point, that's where you find our local. At this point, at this particular point, at this point, that's where you find our local maxima. This is where you find the maximum stationary point here. That's where our graph is at its peak or at its maximum. Then at this point, we find our local minima. That's where our graph is at its lowest peak. Yes. And I've talked about first derivative. That's where you find the coordinates of turning point. Second derivative, that's where you find the point of inflection, coordinates at Tenkofela. And now we need to know about I get you are sketching the graph. So you have learned about stationary points, about turning points. You've learned about y-intercept and x-intercepts. You've learned about local and maximum, local and minimum. You've learned about point of inflection. Now let us talk about the value of a, how a is defined. How a is defined. Now steps to sketching a cubic function. Steps to sketching cubic function. Step number 1, the shape. We talk about the value of a. The value of a should be, it's either if the value of a is bigger than 0, you need to know the shape. If the value of a is smaller than 0, you also need to know the shape. So if the value of a is bigger than 0, if the value of a is positive, basically, our graph increases from the left to the right. This is how it looks like. This is how it looks like. Yes, this is how it looks like. Our graph is increasing. Seems our graph is increasing here. This is how it increases. At this point, from this point to this point, our graph is increasing from the left. And here it decreases again, but it starts increasing again from the right. Now, guys, so it increases from the left and right, And if the value of A is negative or it is more than 0, if the value of A is negative, our graph is decreasing from the left to the right. This is how it looks like. Yeah, well, seems our graph is decreasing from this point to this point again. From the left, our graph is decreasing, it's negative. Then it increases to this point, and at this point again, from the right, our graph is decreasing. That's how you literally know. That's how you find the value of A. This is how your graph looks like. It increases from the left to the right. It also decreases when the value of A is negative from the left to the right. So that's how you identify. Step 2. Step 2, we talk about intercepts. Intercepts, I get what guys. X and Y intercepts. We learn about, we use vector theorem to find our initial vector. Then maybe after we use quadratic equation, if the resulting quadratic equation does not have vectors, so you're gonna use a vector theorem to find the first bracket. That's like the way we did in the previous sector. We use vector theorem to find our initial vector. Then the second bracket is a quadratic equation. You simplify a quadratic equation. How do you find the second bracket? Through synthetic or inspection. So the second bracket you use to find through inspection couple synthetic division. Then the first bracket is through vector theorem. You learn about those concepts when you proceed. Then the step 3, we're going to talk about the stationary points. Stationary points. Stationary points. Or turning point. Some they say turning points. Thank you guys. Turning point is where the graph goes from increasing to decreasing or vice versa and has a local minimum and local maximum. That's like I've mentioned, guys. The graph has got local maximum at this point and local minimum at this point. That's where we find our stationary points or turning points at this point. Then the last step is step number 4. Step number 4, that's where we talk about point of inflection. Point of inflection is where the graph goes from concave up to concave down or vice versa. This is our point of inflection. Our graph goes from concave down to concave up. We're going to talk about that at a later stage. That's where we interpret the graph. Yes, guys. Let us do some few examples. But you must remember, these things are very simple. Let me just draw the graph of this function. Let us draw the graph of this function. Let us draw the graph. Let us draw the graph of this function. Let us draw the graph of this function. F at x is equals to x cubed minus 4x squared plus 4x. Draw the function. Draw the graph of this function. Now you need to know, first step, shape of the graph. Shape of the graph. Now the value of A here is 1. Therefore our graph is increasing, it's positive. That means the value of A is bigger than 0, and that means it is increasing from the left and to the right. It's increasing from the left to the right. This is how the shape of our graph will look like. Step number 2, intercepts. X-intercept and y-intercept. Now, the number 1 again. Number 2, x and y-intercept again. So, y-intercept is so simple again. Y-intercept, you let x be 0. So, it's y equal to 0 cubed minus 4 times 0 squared plus 4 times 0. Our answer is 0. Therefore, the coordinates of our y-intercept is at origin 0 and 0. That means our graph will touch the y-axis at the origin. Then x-intercepts. X-intercepts, you let y be 0. So we're gonna have 0 is equals to x cubed minus 4x squared plus 4x. So you solve for x here, basically. You are solving for x. Basically, how you solve for x in this case, you have a common factor of x, because x is present on our last term, x is present on our second term, and x is present on our third term. Therefore, we're going to take out x as our common factor. So you're going to have 0 is equals to x bracket first term divided by our common factor, x squared. So x cubed divided by x is x squared minus 4x squared divided by our common factor, which is x, is 4x. Then 4x divided by x is plus 4. Now I can see this is a quadratic equation inside here. I have opened 2 brackets because this is a quadratic. So I'm going to have 0 is equals to x, so 2 brackets. So there's no need for you to use inspection here or synthetic division, because already you have a quadratic equation. Then factors of x squared is x and x. Which number can I multiply to give me 4? Add or subtract to give me 4 again. So 2 times 2 is 4. 2 plus 2 is 4. That means 2 and 2 are factors here. So I'm going to have 2 on this side, 2 on this side. So 2 times 2 is 4. The sign, the bigger number takes the sign of the middle term. So between 2 and 2, which one is bigger? That means there is no bigger number. That means we're going to have, you can put negative on any of the 2 sides. You can put negative on this side. Now, I need another sign I can multiply with this negative sign to give me positive sign here. So negative times negative is positive. But negative times positive, it is not positive. Instead, negative times negative is positive. Negative 2 minus 2 is negative 4. Negative 2 times negative 2 is positive 4. Therefore, I'm done with my factors. Let me just equate the equation. So we know go to therefore. Let me just write it here on top. Therefore, I equate my product to 0. My first product is x. X is equal to 0. Or so x minus 2 equal to 0. So I'm going to have x minus 2 equal to 0, or my last product is x minus 2 again equal to minus x minus 2 equal to 0. So therefore, these are my coordinates: x equal to 0, or x equal to 2, or x equal to 2. But here we have 2 coordinates of x. That means we are not allowed to. It's not a must to write them, because we're gonna have coordinates. I think is 0 and 0 and 2 and 0. So it's not a must to write coordinates of this point again. So I already have 2 here, so I don't need to write 2 again, coordinates of 2 and 0 again on this part. So you're not allowed to do that. So it's not a must actually. So I already know. Remember guys, the coordinates of our x-intercept remember I told you that they act as a turning point and x-intercept in most cases. Since our graph turns in most cases where it touches the x-axis, since we can find our turning point from our x-intercept already. I hope you can literally hear me. Now let us find step number 3. Remember, step number 3, you must find the what? You must find the coordinates of a stationary point. Coordinates of our stationary point. Coordinates of our stationary point. So coordinates of our stationary point, guys, it's so simple to find them. Remember, step number 3, coordinates of our stationary point. So I need to remove this part. So I'm just gonna write them here. I need some space. So I don't have capacity, guys. So yeah, I don't have capacity, hence I'm removing. So we already know coordinates of y-intercept is 0 and 0 here. Then x-intercepts, there are 3, 0 and 0, and 2 and 0 here. Yeah, yes, let me just remove them here. So for space preservation, to preserve some space here, guys. So guys, let me just find step number 3, stationary points, couple turning point again. I just removed the coordinates of our x-intercepts there for space preservation again. Yes. So now, how do you find coordinates of our turning point? Remember, you let our derivative be equal to 0. So you derive this and equate it to 0. Let us derive this function. So 3 times 1. So we have 3 times 1 is 3. 3 minus 1 is 2. 2 times -4 is -8. 2 minus 1 is 1. Plus, obviously, 1 times 4 is 4. 1 minus 1 is 0. Then x power 0 is 1. Therefore, we have a constant there. This is a quadratic equation, open two brackets, or we can literally use the quadratic equation to find the factors. But to save time, we want to have something like this, open two brackets. When I can use quadratic equation, guys, factors of 3x squared is 3x and x, which number can I multiply to give me 4? But since now we have 3x here, and we'll have 2 times 2, 2 and 2. I'll teach you guys, how do you find factors if the coefficient of x squared is bigger than 1. I will teach you it sometime, but right now we don't have time. So it's 2 times 2 is 4. The signs are on negative times negative is positive, and negative and negative. So my first product to 0, my second product is so for x. So I'm going to have 3x minus 2 equal to 0, or x minus 2 equal to 0. Then 3x, I transpose this 2 to the left, to the right, and divide both sides by 3. Therefore, x is equal to 2 over 3, or x is equal to 2. I found my x coordinates through this way. Therefore, these x coordinates, I'm going to substitute them back to the general equation to find the y coordinates. That's how you find stationary points. You only do this if you find stationary point. You derive and solve for x. After you solve for x, these x values you have found, you substitute them back to the real, not this one, to a real equation to find the y coordinates of our function. I hope you can hear me. Now, f at 2 over 3 is equals to, where I see x, I put in 2 over 3 to find y coordinate. So I'm going to have 2 divided by 3 cubed minus 4 times 2 over 3 squared plus 4 times 2 over 3. Therefore, f at 2 over 3 is equals to, so you just put 2 over 3 cubed on the calculator. So you're gonna get, so I would advise you guys to use decimal so that you can know how to plot them on the graph. So I got 32 over 27, okay? Then in decimal form you have 1,186, 1,2 actually, 1,2. Therefore my coordinates is 2 over 3. I can literally change that 2 over 3 to decimal, Leona. We find 0,7, I get 67, so it's 7 and 1,2. So this is in decimal form, okay? Then I'm gonna take my another x is f at 2, okay? So f at 2, where I see x I put in 2, so 2 cubed is 8, okay? 4 times 2 squared is 2 times 2 squared is 4. 4 times 4 is negative 16, okay? So it's 8 minus negative 16 is negative 8, okay? Negative 8 plus 4 times 2, negative 8 plus 8 is 0. That means my coordinate is 0 here. So coordinates of this one is 2 and 0. I'm done with finding the coordinates of my stationary points. So my stationary points here, my turning point, stationary points or TP, coordinates I think it's in another, yeah? 0,7 and 1,2, 0,7 and 1,2. Another one is 2 is to 0, 2 is to 2 and 0, not 2 is to 0 actually. 2 and 0, ne? Let me just write them proper. Yes, so it's 0,7 and 1,2. Other ones is 2 and 0, guys, ne? So let us find coordinates of point of inflection. Coordinates of point of inflection. So coordinates of point of inflection, you find them already. Let me just remove. So now you see what I've left this equation. This so point of inflection. I get this one is already. I get this one is the derivative. First principle, first derivative, yeah. But for point of inflection is second derivative. So it's second derivative is equal to 0. So this equation, not this one. You can take this one and derive 2 times, and it's not a problem. But use this one already of a stationary point to derive for the second time from this one, ne? To save your time. So we derive this for the second time. 2 times 3 is 6, yeah. 2 minus 1 is 1. 1 times 8 is negative 8. 1 minus 0 is 0. Then therefore this is equal to 0, yeah. Now I'm going to transpose this 8 to the right, equal to 8, yeah. Then you divide both sides by 6, yeah. Therefore your x is equals to 8 divided by 6. We're going to have 2 times 4, 2 times 3. So we're going to have 4 over 3. 4 over 3 as our x coordinate. Then this 4 over 3, the very same thing you did with finding stationary points. You take this x coordinate, you put it to the real equation to find the y coordinate for this function. So we're going to have f at 4 over 3 is equals to 4 over 3 to power 3 minus 4 over 3 squared plus 4 times 4 over 3. If we put this in a calculator, you're going to get, let me just check, 16 over 27, but in comma is 0.59. So you got 0.59. So let's just put the coordinates properly. 4 over 3 in comma. I do this because I can plot the graph properly without any. So for 4 over 3, I have in this one, 4 over 3 is 1,33, 1,3, let me just say 1,3 and 0.59. These are coordinates of our point of inflection, guys. These are coordinates of our point of. So guys, these are coordinates of our point of inflection, 1,3 and 0.59. Stationary point ka turning point ke tsena na 0.7 and 1,2 and 0 and 2 and 2 and 0. X-intercept is 0 and 0, 2 and 2, 2 and 0. Y-intercept is 0 and 0. Shape of the graph, we're expecting something like this, ne? Yes, we're expecting something like that. Let us draw the graph. Let me just draw the graph very fast, guys. Just gonna draw the graph. So this is how it looks like, ne? It's not perfect, but I think this is how it will look like. So this is our Cartesian plane here. This is our Cartesian plane. This is how it looks like. And then guys, this is our Cartesian plane here. Let me just plot the coordinates. Okay. Let me just plot the coordinates. And 0 and 0. Here is it. Here's our 0 and 0. Here's our 0 and 0. Let me just use a different color. Let's use a different color. Brown. Yeah. 0 and 0. Code origin here. Then x-intercept 2 and 0. 2 and 0 is on the left, on the right, I mean. Here. Stationary point 0.7 and 1.2. So 0.7 is between here and maybe up here. Then 2 and 0. Oh, guys, this is our turning point. 2 and 0. That's where our graph tends. That's where our graph tends. Yeah? Here at 2 and 0. Remember? So I told you good. Sometimes x-intercept and our turning point they can share one coordinate. Yeah. Yes, they can share 1 point each one. At this point, that's where graph tends. Yeah. So it either goes down or up. It will depend. But since we know the value of a is bigger than 0, it means our graph possibly might go up. At this point, it might go up. I don't know. I'm just predicting. Yeah. We'll check. Don't worry. Then these are coordinates of our turning point. So inflection, point of inflection, we've got 1,3 and 0.59. 1,3 is bigger than 0.7 here, so it means it just extend this point. We can have 2 here, 2 and 0 here, and 1,3 is bigger than 0.7 here. That means we might have a point here. Now guys, so we know that the value of a is bigger than that, means our graph here it goes like this. Ne? So our graph, let me just this one put it here. So our graph might go like this. Ne? our graph might go like this. Now guys, this is how our graph will look like. This is how our graph looks like. Ne? I hope we can see it. This is how our graph will look like. We know that it's increasing. Sometimes it might not look similar. Sometimes it will depend on the coordinates, how our coordinates are shaped here. So let me just label them. Let me just label them for you. So it's 0 and 0. Let me just use a different color here. So it's we've got 0 and 0 here. 0 and 0. At this point, it's our turning point here. 0,7 and 1,2. At this point is our point of inflection 1,3 and 0,59. Yeah? At this point we got our turning point, even also our x-intercept, which is 2 and 0. So our graph, you know what it tends at this point, yeah? And you know it's increasing. Yeah? It's positive. It's positive. Yeah? Our graph is positive. It is increasing. Yeah? That's how you see. That's how you know what our graph is increasing. Yeah? This is how our graph will look like, guys. I hope you can hear me. I hope you understand that. I hope. Let's go to the next example. Let's go to the next example. The simplest example ever. Another example, guys. It's so simple. You can pause the video and do this one. Pause the video and do it. The very same way we did this one. Pause the video and do it. You can pause the video, guys, and do it. You can pause the video and do it. This one is very simple. So now we have f at x equal to negative x cubed plus x squared minus x minus 3. To show the graph of this function, you can pause the video and go through the example. Here's an example, guys. You can go through it. You can pause the video and go through it. Negative x cubed plus x squared minus x minus 3. Draw the graph of this function. First step, the shape. The shape of our function. The value of a, it is smaller than 0 here. It is negative 1 here. So it means our graph is decreasing from the left and right. So our graph is decreasing. How it will look like this? It will look like this. This is how our graph will look like. Will possibly look like, not exactly, but will possibly look like this. Our graph, it will decrease from the left and decrease from the right. That's how you define the shape of the graph if the value of a is negative. Step number 2, intercepts. You know what you start with y-intercept. Y-intercept, let x be equal to 0. So it's y equal to negative 0 cubed plus 0 squared minus 0 minus 3. All this equal to minus 3. Therefore, coordinates of our y-intercept is 0 and minus 3 or negative 3. Then now, x-intercepts. X-intercepts, you let y be 0. Where I see y, put in 0 there. 0 is equals to a negative x cubed plus x minus 3. So I need to solve for x in this case. So now, since all now I can see that the value of a is negative 1, or we have negative 1 in front of our x cubed. I need to divide each and every term by -1. I need to divide each and every term by -1 to be left with positive x cubed. Okay? So I'm going to divide each term by -1. So I'm going to have positive x cubed. Negative divided by positive is negative x squared. Sorry guys, x squared. Negative divided by negative is positive x. Negative divided by negative is positive 3. Then I'm okay with that. Then remember, I'm going to use a factor theorem to find the initial factor. Yeah? I'm going to use factor theorem to find the initial factor. Factor theorem in this case, I'm going to use my calculator. Where I see x, I put in 1, -1, 2, -2, 3, -3, and so on. Let me just do that proper. So I'll start with positive 1. Where I see x, I put in 1, -1 squared plus 1 plus 3. When I put 1, I get a positive 4. That means it's wrong. Then just put in -1 here. Where cx, -1, -1, where cx, I get 0. That means -1. Then f at -1. When I put -1, I get 0. That means x plus 1 is a factor. So can you remember when you take this -1, inside the bracket is x plus 1. X plus 1 bracket. The second bracket is a quadratic. Our second bracket is a quadratic equation here, basically. So now, x times which number or which factor can I multiply with x to give me x cubed is x squared. So I'm going to have x squared. Remember guys, this equation is different from our first example because our first example, we had a common factor. In this case, we don't have a common factor. So we're going to use either synthetic or inspection to simplify, to find the factors here. Now, our second bracket, our second term in this second bracket, we don't know it yet. We're going to have plus bx. Then which number can I multiply with 1 to give me 3? A constant here. 1 times 3 is 3. So I'm going to have plus 3 here. I close the bracket. Now, my aim. Now, guys, in this case, our aim is to find the value of b. Yeah? We're going to use inspection to find the value of b. When I can use synthetic division. Yeah? It's not a problem to find the value of b through that process. Yeah? Let us use inspection. In inspection, now we have used factor theorem to find the initial factor, which is -1. Yeah? That's how we use inspection. In inspection, we're gonna say, okay, how do you find the value of b? Through inspection. Yeah? Now, I'm gonna take a term with a squared, which is, in this case, we have -x squared. Yeah? I'm going to take this term and equate -x squared equal to. Now, I need to find two product or two factors that when I multiply them, the resulting factor must have squared. I hope you can hear me, guys. So I need to be very considerate of your understanding. Now, I will just repeat it. I need two factors from this equation. That's when I multiply them, they give me something with a squared on it. So I know that guys, x times x squared is x cubed. It means it does not apply here. But x times bx, x times x is x squared. That's what I want. That means x times bx, it applies to be used here. I hope you can hear me, guys. X times bx, it can be used because x times x is x squared. Ne, guys. Ne. I hope you can literally hear me. Ne. So let me just write it down. I know that. Let me just write it here. I know what x multiplied by bx. Then I'm going to say plus in the middle. And another product again. I'm going to find another factors. That's when I multiply, they give me x squared, double squared. I know again that 1 times x squared is, it has got squared here. It has got a squared. 1 times x squared, it gives me x squared. So I'm going to write here on top. I'm going to write on top there. I'm going to write on top. So I'm going to write on top here. And you know, 1 times x squared is, and as long as I get something with a squared, it's not a problem. But I only need 2. So 1 times x squared is x. 1 times x squared. It applies also. Then from this, solve for b. From this equation, solve for b. This is how you use inspection, guys. From this equation, solve for b. From this equation. Ne, guys. Now from this equation, you need to solve for b. Ne? Solve for b. How do I solve for b? So, phone your board. So how do I solve for b in this case, guys? So I need to solve for b. So I'm going to say x times bx. X times x is x squared here. So I'm going to have b x squared here plus 1 times x squared is x squared here. So I'm going to be left with, on this side, I'm going to have negative x squared here. Then like terms, let me just remove this thing. Then my like terms, like term, and just I transpose it to the left. So I'm going to have negative x squared minus this x squared equal to bx squared. Then give like terms again. When I have negative 2 x squared here, because negative 1 minus 1 is negative 2x squared equal to b x squared. Then I divide both sides by x squared here. X squared, x squared. This x squared divided by this next x squared, we're left with negative 2. Therefore, the root of b is negative 2. So in this equation, where I see b, I put in negative 2. That's how you use inspection to simplify or to find factors. Therefore, 0 is equals to x plus 1. We have x squared minus 2x plus 3. Therefore, this is a quadratic equation, guys. This is a quadratic equation. You can open 2 brackets again. So we're going to have 0 is equals to x plus 1. You open 2 brackets. The factors of x squared is x and x, and x then which terms, 2 terms, can I multiply to give me 3, my last term, add or subtract to give me my middle term, ne? So what's about it? 3 times 1 is 3, 3 minus 1 is 2, and so like 3, we can use quadratic equation, guys. I mean 3 and 1, not 3 and 3. So that's 3 and 1. Then I know 3 minus 2 is 2, but the sign itself must be different. The bigger number takes the sign of the middle term. Which one between 3 and 2 is big? It's 3, That means 3 should take the sign of my middle term, which is negative 2. Which means this negative should be right here. Then I need to multiply my term my 2 terms here to give me my last term. I know negative times negative is positive. That means negative 3 times negative 1. It gives me positive 3. But no, it's going to be wrong. It's going to be wrong, guys. I think it's going to be wrong. Oh, so guys, I don't know what's happening here. I don't know what's happening. Something is happening here. I don't know what's happening, guys. So we have, I think this one does not affect us, It does not affect us, this one, because negative 3 minus negative 1 is negative 4. Negative 3, but it's correct when you say negative 3 times negative 1 is positive 3. That means it does not affect us, this one. So if it does not affect us, you confirm it by using the quadratic equation. You confirm it by using quadratic equation. Indeed, this one does not affect us. Let me just remove the last part and use quadratic equation to find the factors of my quadratic equation. X squared minus 2x plus 3. So we have x equal to plus or minus b. Sorry, negative b plus or minus square root of b squared minus 4ac over 2 times a. Then negative 2. And guys, I hope you know quadratic equation. Negative 2 plus or minus square root of negative 2 squared minus 4 times a 1c 3, all divided by 2 times 1. This equal to, so let me just put this on calculator. Let me say 2 function 2 plus, or set with plus, negative 2 squared minus 4 times 1 times 3. This equals to 2 times 1 here. It gives me math error. That means there's a problem here. Let me just put this thing further on a calculator. Here square root say will give us the value of b squared minus 4ac. Let me just put whatever that is inside the square root to see if the answer is going to be negative or positive. It means just negative 2 squared minus 4 times 1 times 3. So guys, the value inside the square root b squared minus 4ac is equal to negative 8. That means my delta, it is smaller than 0. That means there are no real roots. There are no real roots here, guys. These are complex numbers. So this equation does not have real roots. That means there are no factors for this equation. That means our graph won't touch the x-intercept. That means this is how it looks like. So this is what you write. You must write this. It's a mark if you write this. You must show good. There are no factors there. Guys. So guys, when I put in my delta, negative 2 squared minus 4 times 3, it gives me negative 8. That means negative 8, it's smaller than 0. That means there are no real roots for this quadratic equation. So there are no factors basically for this quadratic equation, and here there are no factors for x squared minus 2x plus 3. That means you must leave it like that with no factors. There's only one factor, which is this one. There's only one factor for this one, which is -1 and 0. Coordinates of x-intercept. There's only one coordinate of intercept, which is -1 and 0. But for this one, there are no factors. Hence, we've gone through this way. There are no factors for this one. I hope you can hear me. Now, step 3. We are done with x-intercept. We are done with y-intercept. We are done with the shape. We go to stationary points. Stationary points. Stationary points couple. Some call it the turning point of the graph. Turning point of the graph. Turning point of the graph. You know what the first derivative is equal to 0. First derivative is equal to 0. That means we must derive this equation. So let us derive it. 3 times -1 is -3. X 3 minus 1 is 2. 2 times 1 is plus 2. X 2 minus 1 is 1. Minus 1 times -1 is -1. Then 1 minus 1 is 0. Then 0, x to the power 0 is -1. Yeah? This is equal to 0. Guys, that's how you derive. I hope you know how to derive. Let's go back to first principle, or let's go back to even the rules of differentiation. You know how to derive. Please, guys, please. Now we have this equation here, so you can divide. So it's a choice. You can use quadratic equation at the very first time, or you can literally simplify it to the fullest here. It's a choice. Whatever you do, you are still correct here. So it's literally your choice. Now I can put this in a quadratic equation here. So when I can see that there are no factors. There are no real factors here. But let me just confirm everything with my mother equation, quadratic equation. So it's -2 plus or minus square root of 2 squared again. Minus 4 times a is -3. Times c is -1, all divided by 2 times -3. Next. Now I'm gonna put this on my calculator. I'm gonna have -2 plus. I'll start with plus here. 2 squared minus 4 times -3 times -1, all divided by 2 times -3. My answer gives me math error. So we must confirm it twice, which it don't make a mistake, But if I can put this, it's math error, but I need to make sure that my square root indeed I find negative value inside my square root here. 2 squared minus square root of 2 squared minus 4 times bracket of -3 times bracket of -1. Then my b squared minus 4ac is equals to, my b squared minus 4ac is equals to 4 minus 4 times -3. It means the value of this is smaller than, it gives me -8. That means the value of my delta, it is smaller than 0 each one. Therefore there are no real roots. Don't worry, guys. Don't worry about whatever you're thinking about. Okay? This is indeed the case. So there are no stationary points, basically. There's no turning point, basically. I could say basically there's no turning point of this graph. Ne? But yeah, I think there's no turning point. But we'll see from the time we draw the graph. Ne? So there are no stationary points. We move. But it's very important for you to write. Ne? You guys, I removed the first derivative. But then the first derivative, I just remember the first derivative I want to give negative 3x squared plus 2x minus 1. Yeah. Then point of inflection. Inflection. You know what the second derivative should be equal to 0. Yeah. That's the principle of finding the point of inflection. Yeah. The principle now, guys, the principle of finding the point of inflection is by saying let the second derivative of f at x be equal to 0. That's how we find the point of inflection. Now I'm going to derive this again. 2 times negative 3 is negative 6. X plus 2 equal to 0. Solve for x. So you need to solve for x there. You're going to have negative 6. X equal to negative 2. You divide both sides by negative 6. Negative 6. Then your x is equals to 2 divided by 6 is 1 over 3. And yet, then you take this 1 over 3, you put it back to the real equation to find the y-coordinate of our point of inflection. So it's f at 1 over 3 is equals to negative 1 over 3 cubed again, guys, plus 1 over 3 squared minus 1 over 3 minus 3. And you put this on a calculator, it's going to give you how much? Negative 88 over 27. But if you put it in comma, if you write it in comma, you're gonna get negative 3 comma 3. Therefore our coordinates are 1 over 3 in comma, in decimal, it's 0 comma 3 and negative 3 comma 3. These are coordinates of point of inflection. Guys, yeah, these are coordinates of our point of inflection. Now let us draw the graph here. Let us draw the graph of this function. So let's remove this part. Just remove this part. Just remove this part. These are coordinates. I'm not going to remove them. So it will be like that usually. So you just draw the graph of this function. Just draw the graph. Just draw the graph of this function. So guys, let us plot the coordinates there. The coordinates. Let me just plot the coordinates. Y-intercept 0 and negative 3. 0 and negative 3. Over here. X-intercept negative 1 and 0. And you can see negative 1 and 0 is here. Then point of inflection 0,3 and negative 3,3. That means negative 3,3 is slightly below negative 3. This one here. That means we have a point slightly here, slightly below our negative 3. Now guys, how will you draw the graph of this function? I know some will draw something. No guys, this is a calculus graph. So we know it is increasing, decreasing. We are expecting a graph like that one. So it will be like this. It's increasing. So we have something like this. We have something like this. Something like this. And it will go like. I need to make justice for you guys to know to draw the graph. So I need to try my best to draw it. Yeah. No. Hey guys. Let me just. No, guys. This is not how it looks like. I need to make justice. Yeah. This is how it looks like. This is how it looks like. Yes. Yeah. This is how it looks like. Then we have our point of inflection here. Yeah. This is how it looks like. Coordinates. We have negative 1 and 0. We have 0 and negative 3. And we have our point of inflection, which is 0, 3 and negative 3, 3. Negative 3, 3. These are coordinates. This is how we draw the graph of this function. So it, guys, it's very important. So this one can go like this. So let me just remove. So it's still correct, but I just want you to look at how it goes like. So it's like this. This is how it looks like. Very simple and unique. Yeah, I think I've made justice, guys. So hence it's very important to know the shape of your graph. It's very important to know the shape of your graph. If the velocity is negative, you know our graph should decrease from the left, and after it has reached the point of inflection, it should decrease from the right also. So it should decrease on both sides. Our graph, guys, will decrease on both sides. Our graph should decrease on both sides. Homework. I'm done with drawing graphs. Homework. Here's a homework. Here's a homework. 2 problems here. Here's a homework. Homework number 1. We have f at x is equals to 1 over 3 x cubed minus 1 over 2 x squared minus 12x plus 8. Number 2, we have got f at x is equals to 9x plus x cubed minus 6. The last one, we've got h at x is equals to negative 2 x cubed plus x squared plus 8x and minus 4. This is your homework. For this section, I'm done with drawing graphs. I'm done with drawing graphs, guys. Yeah. And in our next section, so we'll talk about graph analysis. So the next session we're going to talk about, we're going to analyze graphs, graph analysis. We'll talk about it, don't worry, we'll talk about graph analysis at a later stage, not now. So I owe you this lesson of graph analysis. How do you analyze a graph? Maybe if you are given a restriction, if they say f at x is bigger than 0, what do they mean here? They will say find the x values for which f at x is bigger than 0. So we'll analyze this graph not on this section but on the later section here. We are still dealing with graphs, drawing graphs, finding equations. So we'll deal with the graph analysis at the later stage. Now the last part of the graphs is determining the equation of a cubic function. How do you determine the equation of a cubic function? This is the next part of our session. So as our next session, which is the last one of our series of calculus, is determining the equation of calculus graphs. Determining the equation of calculus graphs. Now, you know that the standard form sa graph ke f at x kapo y kapo g at x, whatever, a x cubed plus b x squared plus c x plus d actually. Now, one of the ways to find this is our standard equation here. This is our standard equation. This is our standard equation here. Ax squared, ax cubed plus bx plus cx plus d. This is our standard equation. Now, one of the ways to find the equation of this function is by through this formula. You can use this formula to find the equation. X minus x1, x minus x2, and x minus x3. Remember, in parabola we had only 2 brackets. Now we have 3 brackets because of this cube. Now, this 3, this x1, x2, x3, all of these 3 x's are our intercepts. These are our intercepts of the graph. x1, x2, x3. Then x is the same value. X is just a value. It's just a point on the graph. Now, when we are required to determine the equation of a cubic function, we will usually be given one of the 3 scenarios. So usually when we want to find the equation of this graph, we will be given all 3 intercepts, x-intercepts. We'll be given all 3 x-intercepts. Then they will say, we will do an example about that. Then the second part will be given a stationary point and one other point on the curve. Then the last scenario will be given 2 stationary points. Then they will say determine the equation of the function. And yeah, now case number 1. Case number 1. I said that's where we'll be given. All 3 x-intercepts. If you're given 3 intercepts, maybe they will draw a graph, ne? Then they will say determine the equation of this graph. Then they will show you on the graph, okay, here are 3 x-intercepts, ne? For an example, if I can draw, let me just say a curve, ne? Not this one. Yes. Let me just draw a curve with so you guys let me just leave it. So case 1, if you are given all 3 x-intercepts, then you will use this equation to find the coordinates of, the equation of this function. So now, to determine the value of a, now here you are given 3 x-intercepts, you will then require to find the equation. Then you will substitute those 3 intercepts, and here they will give you a graph, and they will show you those 3 x-intercepts. After you have substituted them, okay, to find the value of a, you need to be given 2 things. The first one, they need to give you the value of a itself here. Alright, they can say here it's 2. They can say here it's 2. They can give you the value of a itself, and may be given to us. It may be given to us in the equation. They can give you this equation. They will say determine the equation of this function. Graph ya offer the coordinates are x-intercepts. So it will be like this. Then you just put in 2 here again, and substitute those coordinates at the x-intercept. Then you simplify the brackets out and have an equation like this one. Then we'll be able to point out B, C, and D. Simple, ne? Then scenario number 2, you might be given one other point on the curve. So they might not give you the value of A, ne? They might not give you the value of A. Then they will give you a point on the graph. Then that point, they can give you 2, maybe, and -3. It's just a point on the graph. It's not a turning point. It's just a point. Then you just say where you see x, you put in 2. That means here you're gonna put in your 2. You're going to have a 2 here and have a 2 here. Then -3 you put in where you see y. On your left you put in y, which is -3. Then you solve. Then you'll be given 3 x-intercepts here. You then substitute them here and solve for a. Then you'll be done with this one. I hope we can hear you. Now guys, Then when we are given a graph with one of its turning point on the x-axis, so sometimes they can give you a graph like this one. They can give you a graph like this one. Hey. Yes, they can give you, not this one, each one. They can give you a graph like this one. Hey. Yes, they can give you a graph like this one. And so this one has got two x-intercepts. Now, if we are given a graph like this one, they should tell you, maybe this is our axis. Yeah. They tell you, this point here is maybe 1 and 0, and this one is -2 and -0. Now, the formula to use for this one is got a turning point and an intercept in this case. That means you have a turning point and an x-intercept at one point. So the equation for this one, you're going to have f at x be equal to x minus x1 x minus x2 squared. So here we're going to have squared, but don't stress about it. So we'll have a squared here. This squared will represent, it will mean that we've got something like this. It will mean we've got something like this, x plus 2, and then we've got x minus 1 x minus 1 again. That means we have two brackets of x minus 1, hence we have squared here. So it doesn't mean nothing, just these are x-intercepts. So we have x plus 2 x minus 1 x minus 1. It means there are two brackets of x minus 1, hence we have squared on our equation. Don't stress about it. It's something that is regular. Some question like this appear. Don't stress. Example number 1. Example. Here's our example. Okay. Example, do you see? We have a function, a graph below. We have a graph here. Here's the equation: 2x cubed plus b x squared plus c x plus d. Then they will say, here's a graph. I'll draw the graph roughly. Here's a graph, guys. Hey, it seems like a Stein graph or something. So here's a graph. So here's a graph. So we're giving coordinates of our x-intercepts. Then we've got our 2 and 0 here. Then they will say determine the width of the equation. They will say determine the equation of the graph. Guys, now you are giving the coordinates of our x-intercept. You use this equation, remember. So let's say y is equals to x minus x1 x minus x2 x minus x3. Then x1, this one, x2, this one, x3, or whatever you can put there. So you're going to have x minus -1, close bracket, x minus 1. The last one is x minus 2. Then you simplify them out here. So you're going to have bracket of x, negative times negative is +1, x minus 1, x minus 2 equal to y. And but remember, you left the value of a, which is 2, and 2 you're gonna put it here. Remember, it's a bracket x minus x1 again. So it's 2 here, 2 here, 2 here. Now guys, I hope you can literally hear me. So you have 2, you left 2 there, remember? Then I'm gonna simplify these brackets out. 2, 2, 2. I'm gonna write this function or this equation in the standard form to be able to point out the value of b, the value of c, the value of d. Yeah? Let me just do that. So I'm gonna leave out this 2. So just simplify these 3 brackets. Then how do you simplify them out? You leave the first bracket and simplify this first 2. The first 2 brackets, simplify them out. If you leave out the third bracket, you're gonna have x times x squared, x times negative 1, negative x. 1 times x is positive x, 1 times negative 1 is negative 1. Then you close the bracket, you simplify again. Let me just do it for you. So it's x times x, x times negative 1, 1 times x, 1 times negative 1. You close the bracket, then you bring down this x minus 2 again, equal to 2. Then these are like terms here. You minus them. Negative x plus x is 0, minus 1, close bracket, x minus 2 here. Then again, you multiply these 2 brackets here. You multiply these 2 brackets, and you're gonna have x squared times x, x cubed. X squared times negative 2 is negative 2 x squared. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. Then you close the bracket. Then lastly, these are like terms here. So you simplify them out. So if you add them, you're going to say, no, they are not like terms. No, I'm lying, guys. I'm lying. These are not like terms. So you multiply, if there are no like terms inside the bracket, whatever it is outside the bracket will multiply whatever it is inside the bracket here. So this 2 will multiply x cubed. You're going to have 2 x cubed. This 2 will multiply this negative 2x squared. You're going to have negative 4 x squared. This 2 will multiply this negative x. You're going to be left with negative 2x. This 2 will multiply this 2, and you have positive 2. Then from this equation, you must point out the value of b, the value of c, and the value of d. So the value of b is negative 4. So therefore, you conclude again, therefore b is equals to negative 4, c is equals to negative 2, and d is equals to positive 2. That's how you conclude. Then you are done with in terms of ending. This is the equation of our graph. I hope you can hear me, guys. No? I hope you can literally hear me. I hope you can literally hear me. Then now, after you found the equation, question number 2. So guys, remember now, I don't know, let me just find. Question number 2 will say, question number B. Number B will say that these are the equation again. The equation is y is equals to 2x cubed minus 4x squared minus 2x plus 2. Then number B will say determine the x values of the stationary points. Determine the coordinates of the stationary point. Can you please find the coordinates of our stationary points of this equation? Remember, stationary points, when you find the coordinates of stationary point, you say derivative of f at x couple y. Let me just write y. The derivative of y is equals to 0. Yeah? Then you derive this equation. 3 times 2, 6 x squared. 2 times negative 4 is negative 8x 2 times 1 times 2 is 2 and this will be equal to 0. Then I can see that there are no factors actually for this one. So if there are no factors, you dwell to quadratic. So we're gonna have x is equals to negative b. Let me just substitute them already. Negative 8 plus or minus square root of negative 8 squared minus 4ac, all divided by 2 times a, which is 6. Then if you simplify this thing out, you're going to be left with x is equals to, if you put it on a calculator, you're going to have plus or minus 2 square root of 7 all divided by 3. Then this, you've got, and then we're going to have x is equal to positive 2 by square root of 7 over 3, or x will be equal to negative 2 square root of 7 divided by 3. Now this x coordinates, where you see x on our real equation, you put in this thing and also this one to find the y coordinates. Then you'll be done with finding the coordinates of our stationary points. I hope you can hear me, guys. Then the second part, I think there's a long walk to freedom. There's a long walk here, guys. There's a long walk. We're left with 3 pages actually. So we are going so far, but it's fine. It's fine. We'll do it. It's so fine. Oh, it's so fine. Let's do it. We'll be done in a moment. The next part of our equation, the next part of our equation is so simple. The next part of our equation, guys, case 2. Case 2. Remember, guys, they can give you, remember, let me just do another example. So we'll do more examples in another case. In case number 1, they can give you a point. We can say determine the equation of the cubic function shown below if it has x-intercepts. So if you have a graph, let me just draw a graph. You have a graph like this one. So this one is got not this is how not look like this. So will not look like this. And let's say they give you coordinates now, this negative 3 and 0. So it's negative 3 and 0, and it's 2 and 0 mono. And they give you a point on the graph, which is 3 and negative 6. And you'll say determine the equation of this function. Determine the equation of this function. Can you determine the equation of this function next? How will you determine the equation of this function? Now, remember, if you are given 2 x-intercepts, and this is where our graph tends. Remember the concept of squared. So you're going to write it like this. You're going to have y equal to 2x minus x1. Now since now we have two coordinates of our x-intercepts, you're going to have x minus x2 squared. Then you're done. So this 2 here represents a turning point and also an x-intercept. That means you're going to have two x coordinates that are the same. So we're going to have x minus negative 3, x minus 2 squared. So this only happens if and only if a point tends. That's where the point tends. We'll have two x values, x coordinates. Yeah? Then you have y equal to x plus 3, x minus 2 squared. Guys, I forgot a here. I forgot to put in a. Hey guys, I have a literally forget about it. I don't know why. We have a. Ne. Then now you are given a point on the graph which is 3 and negative 6. You are given a point on the graph which is 3 and negative 6. Ne? This means go to where you see x, you put in 3, where you see y, put in negative 6 to find a. Hurry. So y is negative 6 equal to a multiplied by 3 plus 3. X is 3 minus 2 squared. Then now 3 plus 3 is 6. Here 3 minus 2 is 1. Then a times 6 is 6a. Then you divide by 6. Then therefore a will get negative 1. So our equation will be y equal to negative 1 here. X plus 3 x minus 2 squared. Then we can simplify this equation thoroughly to understand form. So let me just simplify it for you guys. So you have negative 1, we have squared here. That means we need to start with simplifying this one with a squared. Yeah? So you can have negative x plus 3. Then if you literally simplify it, open two brackets of x minus 2, then you use FOIL. So you're going to have left with x squared minus 4x plus 4. And if you open two brackets of x minus 2, you're going to have something like this. Then negative 1, you multiply this bracket by this one. X times x squared is x cubed minus x times 4x is 4x squared. X times positive 4 is positive 4x. 3 times x squared is positive 3x squared. 3 times negative 4x is minus 12x. Then 3 times 4 is plus 12. That is a constant. Then in for here x times x squared is x cubed, x times negative 4x is negative 4x squared, x times 4 is positive 4x, 3 times x squared is positive 3x squared, 3 times negative 4x is negative 12x, 3 times positive 4 is positive 12. That's how I got it. Then you simplify like terms inside the bracket. Like terms, there are like terms here. So it's negative 4x squared plus 3x squared is negative x squared here. Then 4x minus 12x, 4 minus 12 is negative 8x. Then a constant is only one constant is positive 12. Then this negative one will multiply each term inside the bracket. Then y is equals to negative x cubed. Negative 1 times negative x squared is positive x squared. Negative 1 times negative 8x is positive 8x. Negative 1 times positive 12 is negative 12. Then you are done. This is the equation of this function. I hope you can hear me, guys. Now, case number 2. Case 2. We are done with case 1. That involves x-intercept. And let's go to case number 2. Case number 2. case 2, case 2, case 2, case 2, case number 2, case number 2, case number 2, ne? That's how it look like. Yeah. Guys, there's a lot of work here. There's a lot of work. Oh. Hi. Case 2, guys, ne? Case 2, if you are given stationary point and one other point on the graph. So if you are given stationary point and one other point on the graph, in this case we need to employ the knowledge that a stationary point is where a stationary point is where the derivative of f at x is equals to 0. And we're gonna use simultaneous equation in most cases to find the equation of this function. So if you're given a stationary point, you need to obviously derive first before you can do anything. Yeah. So example. So if you are given an equation, yeah, if both equation, Mona, Ari, you have y maybe is equals to negative x cubed plus bx squared plus cx plus d. It is a stationary point. So you have a stationary point, let's graph a stationary point at point A. Connect point A 2 and negative 32 and passes through the origin. And passes through the origin. And this graph passes through the origin. Now, determine the value of the value of B, C, and D. Hence, write down the equation of the function. So here's the graph, guys. Here's how the graph looks like. So hey guys, and here's our origin here, and then you have this point. Our turning point is here, point A, which is 2 and negative 32, and is and they're just giving you this. Then they say determine the equation of this function. How will you determine the equation of this function? How will you determine the equation of this function? Simple, ne? Very simple. Now remember, guys. You are given origin. You are given another point on the graph, which is 0 and 0. So this point is just a point on the graph. It's nothing else but just a point on the graph. So you can use this point. You can literally start with just a point in the graph. Substitute it where you see 0, where you see x and y, put that point on the graph, which is 0 and 0. Okay? Sorry, y putting 0 is equals to negative 0 cubed plus b times 0 squared plus c times 0 plus d. Ne? Whatever is 0, then 0 is equals to, therefore d. We have found our d, therefore this is a mark. We have just found d. Simple, ne? You just found d by just substituting our origin on our equation. Simple like that. Guys. Now, we are left with finding b and c. How do you find b and c? Remember, once we have a turning point, a stationary point, will be subjected to simultaneous equation. It will be subjected to that. Now, we know that derivative of f at x is equal to 0. You do this if and only if you are given a stationary point. You derive. Let's derive. 3 times negative 1 is negative 3x squared. 2 times b is positive 2bx, then plus c. Now, when this firstly is equals to 0. This is the first thing you do. You just equate this equation to 0. Then you try to simplify this thing. Then now, after you've put these coordinates to 0, you use the x coordinate of that point of stationary point. Until you have point A, which is 2 and negative 32. For now, you don't use this negative 32, you just use this 2. Where you see x, you put in 2 for now. You use the first x coordinate in all cases. Everywhere you go, you start by using the x coordinate first before using the whole point A. You start by using this coordinate of x, where you see x, you put in 2. So negative 3 times 2 squared plus 2 times b times 2 plus c equal to 0. You don't put in negative 32 where you see y. It's 0. Then you simplify this. 2 squared is 4. 4 times negative 3 is negative 12. Plus 2 times 2 is 4b. Plus c equal to 0. Then I can make c the subject of the formula. Therefore, c is equals to, I take this 12 on the right, this 4b on the right, minus 4b. This is my equation number 1. So guys, then I need to find equation number 2. So equation number 2, how I'm going to find it? So I'm going to say, now, I've done with equation number 1 again. So now, where I see, remember our equation again, it's like this. f at x is equals to negative x cubed plus b x squared plus c x plus, remember d is 0 plus 0. Now where I see, now I'm going to substitute these coordinates back to my real equation. So where I see y, I put in negative 32. Where I see x, I put in 2 here. That's what I'm going to do. So I'm going to have negative 32 is equals to negative 2 cubed plus b times 2 squared plus c times 2 here. So I'm going to have c times 2 plus 0. So it does not matter. That 0 does not matter. Then I'm going to have negative 2 cubed is negative 8 here. It's negative 8 plus 2 squared is 4b plus 2c. Then we left it at negative 32. Then negative 32 plus 8 is negative 2 plus 38 is 32 is negative 24 here, equal to 4b plus 2c. This is my equation number 2. Now substitute sub 1 into 2. This basically means where I see C on equation number 2, I put in 12 minus 4b. Here's my C. Let me just do it. So I'm going to have negative 24 equal to 4b plus 2 times 12 minus 4b. 12 minus 4b. Yeah. Then I'm going to say 4b plus 2 times 12 is 24. 2 times negative 4 is negative 8b equal to negative 24. Then negative 24, I simplify for b. Then if I simplify it further, it will give me b over 12. So I'm going to say negative 24 minus 24 equal to 4b minus 8 is negative 4b. Then I'm going to be left with negative 48 divided by negative 4b. Then negative 4, negative 4. B again, 12. I hope you can see it, guys. Then C, therefore, C is going to be equal to 12 minus 4 times 12. Put this on the calculator. Your B is negative 36. Therefore, I found B, C, and D. Therefore, my equation is y equal to negative x cubed plus 12 x squared minus 36 x. I'm done. That's how you find the equation of this function. I hope we can literally see, guys. Apologies with the camera. We are currently fixing our camera system. It will bounce back to proper quality. Don't worry. Just give us a few days, then we'll simplify. We are still fixing our camera system here. So this is a new system, so we're testing new system here. So please bear with us. Yeah, we're still trying new systems here. We have invested in camera quality, so hopefully before term 3 everything will be sorted. So basically, yes, in term 3 everything will be sorted out. So we have a proper camera, proper system will be in place. So yeah, don't worry, guys. So we provide with material for term 2 examination as we prepare. Yes. So now let us go to the last case, which is case number 3. Case 3, it's so simple. Case number 3, the last one. Case 3, it talks about given both stationary, and this one is more complex but it is both. So if you're given both stationary points, for an example, if you have a function f at x is equals to negative 2x cubed plus bx squared plus cx plus d. We're given the graph has stationary points at point A, 2 and 9, and point B, 5 and 18. Then determine the value of B, C, and D. And let me just draw the graph here. Here's how the graph will look like. Oh yeah. Here's how the graph will look like here. Then just cross there. Yeah. Then our y-intercept will be here and here. Then we have 2 points here. Point A, which is 2 and negative 9. Point B, which will be 5 and 18. 5 and 18. Yes, 5 and 18. Yeah, that's it. Now find the coordinates of BCD. Now, right now, guys, we don't have the origin, so we cannot find the value of D. No? But we only have 2 points on the graph. So now, you know, but before anything else, this is so simple. Now, you need to derive. First thing first. You derive, no? You derive. How deriving? 2 times 3 is 0 is equals to 2 times negative 3 is negative 6 x squared plus 2bx plus c. Now, after you have derived, you put in the x coordinate of any point between A and B. So for point A, we have 2 and negative 9 again. So where you see x, we put in 2. So we're going to have 0 is equals to negative 6 times 2 plus 2b times 2 plus c. And here, then we're going to have negative 12 here. It's squared here. So guys, so it's negative 24 plus 4b plus c. Then I'm going to transpose this negative 24 to the left. So you're going to have positive 24. 24 is equals to 4b plus c. And here, then again, I can leave my c as my subject of the formula for this equation. And here, guys, then guys, I put in 0 here, so c here, therefore c, I want to make my c the subject of the formula here. So c is equals to 24 minus 4b. So I just transpose this 4b to the left, and here, this is my equation number 1. Then how will I find equation number 2? How will I find equation number 2? Equation number 2, I will literally put in again the x coordinate of B. Where I see x, I put in 5. So I go to B. For B, I say it's 5 and 18 here. So where I see x, I put in 5 there. So I'm going to have 0 is equals to negative 6 times 5 squared plus 2 times b times 5 plus c. Guys. Then I know that negative 5 squared, negative 6 times 5 squared is negative 150 here. Plus 10b, because 2 times 5 is 10, plus c here. Then I'm gonna be left with, I transpose here, negative 50 to the left. So I'm gonna be left with, so I might make c the subject of the formula here. So I'm gonna make c the subject of the formula. So this negative 150 to go to the left, this 10 is go to the left again now. So I'm gonna have c is equals to 150 minus 10b. Equation number 2. This is my equation number 2, guys. Then now, I'm not done. Remember, I'm not done. I'm not done. I'm not done, guys. I'm not done. I'm I'm not done with finding the equation of this function. So now, the next step again is to just equate the two equations. I just need to equate the two equations, 24 minus 4b equal to 150, because I can see that I can find literally b again. So I'm going to have 20. So substitute or equate equation number 1 with equation number 2, because I can see that C, and I can equate the two. So I'm going to have 24 minus 4b is equals to 150 minus 10b. This is how you do it, guys. Load shedding. So it's 24 minus 150. Yeah, it's 126 equal to negative 10 plus 4, 6, negative 10, it's just going to be negative, you divide both sides by negative 6, then our b is equal to 21. So divide 126, guys. 126. Then our b is equal to 21. Then you found your b. Then you can find c by substituting. Where is c? B, put in 21 here or here. So we're gonna have c is equal to 24 minus 4 times 21. Our c is equal to 24 minus 4 times 21 is, we keep 60. Then you are done. Now guys, you are done with finding c and b. Then you write your full equation here. And you write your full equation. F at x is equal to negative 2x squared. The value of b is 21 plus 21 x squared. The value of c is negative 60 minus 16. Remember, we don't have d plus d. So we need to find d here. We don't have d, we have d. So how do you find d? You take those coordinates around. Remember, it's a b. And it's a big, coordinates are big. 5 and 18. So you take these coordinates and substitute them back to the real equation to find coordinates of d. So 18 is y, 5 is x. So 18 is equals to negative 2 times 5 squared plus 21 times 5 is cubed, cubed. Please press the calculator there, guys. Minus 60 times 5 plus d. Then you're gonna press the calculator from here to here. And after you found answer from this part, you transpose it to the left and say 18 minus this answer you got here. Then therefore your d will be equal to 43. So I'm done. So here's the value of D. So the value of B is 21, the value of C is -6, the value of D is 43. You are done, guys, with finding the equation of this function. Then you can write the equation. The function is plus 43. This is the function. That's how you find the function of this graph. I hope you can hear me, guys. Now, the last example. So guys, we are done for today's lesson, and the next session we will have question and answer session, wherein we will put our emphasis on previous question papers, and hopefully you will join me in the next session, guys. Before the end of this week, we'll post more videos that involves questions of paper 1 and paper 2 mathematics junior examination preparations. So I hope you're gonna enjoy your day. Thank you very much.